After years of mystery, speculation, and countless theories, the James Webb Space Telescope has delivered an image that could radically alter our understanding of the universe. This image reveals Betelgeuse, the star that has captivated both scientists and skywatchers for years. Many had speculated that Betelgeuse was on the brink of a spectacular explosion, a supernova that would light up the night sky. However, what the James Webb captured goes far beyond expectations. The star's peculiar behavior had kept experts guessing about its fate. Could this be a never-before-seen cosmic phenomenon? Or is Betelgeuse hiding something even more astonishing? Perhaps a new stage in stellar evolution that challenges everything we thought we knew about star life cycles? Scientists are now asking whether this discovery opens up a new field of study, one that could change the way we view not only Betelgeuse, but also other stars in similar stages. This captivating image might push forward not only stellar science but also our understanding of cosmic phenomena on a much broader scale. Betelgeuse, one of the most recognizable stars in the night sky, is a red supergiant located in the constellation Orion, approximately 642 light-years from Earth. It is an enormous star, about 1,400 times the diameter of our Sun, and its intense brightness has fascinated astronomers and stargazers alike for centuries. For years, it has been studied not only because of its massive size but also due to its unusual behavior. Its brilliant red hue and immense brightness make it stand out among other stars, drawing the gaze of anyone looking at the night sky. Its very existence has been the subject of significant interest and has led to both amateur and professional astronomers attempting to predict when it would go supernova, a stellar death event that might be visible to the naked eye. But in recent years, something strange began happening. Betelgeuse, once a shining beacon, started to lose its brilliance. Its light began to flicker and fade, prompting scientists to question whether the star was nearing the end of its life. Was it on the verge of going supernova? Could we be on the cusp of witnessing an extraordinary cosmic event? This was a significant moment, as it challenged the expectations of astronomers who had been eagerly watching its behavior. Both professional and amateur astronomers began speculating. Was Betelgeuse about to explode? A supernova visible to the naked eye would be a once-in-a-lifetime event, an incredible burst of energy lighting up the night sky for weeks or even months. As excitement grew, scientists closely tracked Betelgeuse's every fluctuation. The star's sudden dimming was unprecedented for a star of its size. The media was abuzz with predictions of an impending supernova, and experts tried to calculate when the explosion might occur. This constant monitoring led to many different hypotheses about the star's fate, with some suggesting it could explode within a matter of years, while others speculated it was still a long way from that final, violent death. Theories ranged from Betelgeuse's possible collapse into a black hole to it simply being in a temporary phase of instability. Regardless, the mystery surrounding its dimming caused a frenzy in the scientific community, with specialists across the world poring over data to understand what was going on. Despite the ongoing fluctuations in brightness, the star never exploded, deepening the mystery surrounding it and leaving astronomers with more questions than answers. Enter the James Webb Space Telescope, a groundbreaking tool designed to probe the farthest reaches of space. Webb's true excitement lies in its ability to peer into our own corner of the universe, allowing us to study nearby stars like Betelgeuse with an unprecedented level of clarity. Webb's advanced infrared capabilities provide astronomers with new tools to analyze stars in ways that were never before possible. The telescope was specifically designed to see through the cosmic dust that can obscure our view of celestial objects, allowing scientists to explore the hidden intricacies of stars. The launch of Webb was met with high anticipation, as astronomers eagerly awaited its first images, hoping for clearer insights into Betelgeuse's behavior. The telescope's ability to detect infrared wavelengths meant that it could reveal things that were invisible to earlier optical telescopes. Betelgeuse became one of the telescope's primary targets. With Webb's powerful infrared capabilities, scientists hoped to gain a clearer understanding of the mysterious behavior of this iconic star. Could the James Webb Telescope finally unveil the secrets of Betelgeuse's strange actions and offer insights into the violent processes that dictate its life and death? Scientists were hopeful that Webb's powerful technology would answer the many questions surrounding Betelgeuse's fate. When the first high-resolution images from Webb arrived, they exceeded all expectations. The image captured was nothing short of breathtaking. It didn't simply depict Betelgeuse as the giant fiery star we had known, but revealed something far more complex. The technology on board Webb allowed it to peer into the star's surface in infrared, showing features that would have been completely invisible with previous instruments. Rather than showing a dimming star, Webb's infrared technology exposed hot spots and bright regions on its surface, suggesting that Betelgeuse was far from the fading object many had anticipated. Instead, it seemed to be a star in the midst of intense activity. The images revealed violent eruptions on the star's surface, massive stellar mass ejections that hurled material into space. These eruptions created vast clouds of gas and dust surrounding the star. Far from a dying star, Betelgeuse was showing signs of dynamic, active processes. The star's surface was constantly changing, with dramatic bursts of energy that altered its overall brightness. As different regions on the surface erupted and expanded, they caused the star's luminosity to fluctuate, brightening and dimming. This behavior was unlike anything previously observed in such a massive star, leaving scientists to ponder new theories and possible explanations. This type of activity is highly unusual for a star of Betelgeuse's size. Most stars don't exhibit such drastic and frequent changes, as their behaviors are usually far more stable. The constant eruptions and fluctuations in luminosity suggest that something extraordinary is occurring within Betelgeuse, something that challenges the existing models of stellar behavior. What, then, is happening? Scientists have been puzzled by these new observations. Some believe that the activity we're seeing is a sign that Betelgeuse is entering its final phase before a supernova. Others propose that the star may not be dying after all and could simply be going through a period of stabilization. Some even suggest that Betelgeuse might be undergoing an unusual type of stellar rejuvenation. Regardless of the explanation, one thing is clear: what we're witnessing with Betelgeuse is unlike anything previously observed in a star of this magnitude. The telescope's new data could forever alter our understanding of how massive stars evolve and die, and could lead to the discovery of entirely new phenomena in stellar astrophysics. The stunning images captured by the James Webb Telescope do more than shed light on Betelgeuse's behavior. They challenge our understanding of how stars live and die. The processes that govern a star's death have been well documented, but Betelgeuse's recent behavior suggests that our understanding might be oversimplified. Traditionally, the life cycle of stars has been well understood, with massive stars undergoing a predictable sequence of events before ending their lives in spectacular supernovae. However, Betelgeuse's strange activity suggests that there may be far more complexity to stellar evolution than previously realized. The data collected so far shows that a star's life cycle may be far more complex than we ever realized. The constant changes in Betelgeuse's brightness and the active eruptions on its surface challenge what scientists thought they knew about stellar dynamics, and may encourage a rethinking of models that have been in place for decades. But what does this mean for us on Earth? If Betelgeuse were to explode in a supernova, we would witness an event like no other. The explosion would be visible from Earth for weeks, lighting up the sky like a second sun. While the explosion itself wouldn't pose any danger to us, since supernovae occur light years away, the event would be a rare and awe-inspiring spectacle. It would also provide scientists with an unprecedented opportunity to study a supernova up close, watching as it releases vast amounts of energy and matter into space.